Welcome to this video. Under Physics Foundation, we have another question on laws of motion. And the question says, a car of mass m is on an icy driveway inclined at an angle of 20 degrees, as in the figure below. Determine the acceleration of the car, assuming the incline is frictionless. It's frictionless, meaning there's no friction there present. All right, so the first thing that we're going to do is that we're going to resolve all the forces acting on this car. And to do that, let's use our knowledge on Newton's laws of motion on incline forces resolution. So the first thing that we are going to understand from here is that let us treat this object, the whole car here. Of course, we have the mass, like the mass, which is like the weight, right? Okay, it's acting straight like this. Okay, all right, so we can call this as F, force due to gravity, which is mass times what? Gravity, right? And again, we have, now remember that there will always be a force opposite to the weight, isn't it? And that force is actually the normal force. So how do we calculate it? Now, look, the car is slanting, so the normal force cannot come straight like this, but it will come straight like this, a bit slanting again up like that. That's where the normal force is. So that's our normal force. Let's call it N. That's why it is. And this is just the Y direction, and this one is the X direction. You can see it's X here. Now, one thing that we need to know is that the force, okay, perpendicular to the normal force, from there you draw it straight like that, it will be the force that we'll be looking for, the one that will be responsible for acceleration actually. All right, so we can call that for now, let's not call it like that, because this angle and that angle, by the angle properties, they're alternating angles, so meaning they are equal. That is also theta, meaning if I do this, this becomes my Y and that becomes my X. And because the arrow is going down, if I use cosine multiplying by this will give me negative mass gravity cosine theta. Now in this other part here, I'm having, in the Y, I'll be having mass gravity sine theta. Remember that the Y-axis is always associated with the sine theta, and the X always with what? Cosine theta. Meaning, because now one thing that you need to remember here is this: the direction of the motion of the car is downward like that, and this force here is parallel to that, meaning they are equal, meaning this one is also mg sine theta. Now, are we interested in the Y direction? No, we are not. We are only interested in the X direction, because that's where motion is taking place. So our acceleration is going to come from there. So if we apply Newton's second law of motion, we should be able to come up with the following equation. Okay, so Newton's second law of motion, of course, the sum of forces acting there should be what? Equal to what? Acceleration. We know that, isn't it? But we've said our acceleration is actually in the X direction and not in the Y, meaning we apply X there, a subscript, to just remind us that our acceleration is actually in the X plane. Now that we know that, let's take all the forces acting in the X direction. So we have this friend of ours. Now it's frictionless, meaning there's no friction. If there was friction, I could have drawn another arrow here for friction and so forth, but it's a simple mechanical question. All right, so what force do we have in the X here? We only have mg sine theta, meaning this is mg sine theta. This is equal to mass acceleration in the X. You divide by mass, you'll be getting acceleration in the X is equal to gravity sine theta. Gravity 9.8, the angle was 20, So now let's punch on the calculator. And I'm getting 3.4 meters per second squared. That's my acceleration. Now, just a bonus. Have you seen the forces in the y? These are the forces acting in the x, giving us that acceleration. What about in the y? How would you resolve them? Well, in the y, we have this, and the normal force. Meaning in the y, do we have the acceleration? No, meaning acceleration in the y is 0. So where you are putting ma here, as in the y, it is 0. All right, but we have minus mg cosine theta plus n is equal to 0. As you can see that the one here coming down here is negative mg cos theta, and that one is n. So they're perpendicular. So plus 1 is positive, equal to 0. So you discover that the normal force is actually equal to mass, gravity, and cosine theta. Just in case they asked you to find the normal force, you would have to put the number, the actual value of the mass. Force gravity is known, theta is known. But for now, our question was asking us to find the acceleration, which you've done. Please subscribe. If you want more questions to be solved, please you can comment, and on which topic exactly.